Let me start this recording. All right, folks, welcome. Shark in the Wire, part 3. Okay, we're gonna go over some Wireshark basics, scenarios, what have you, how to use it to troubleshoot. This session tonight is gonna be real short. We're gonna go over how to, follow a conversation. What does that mean, right? On a lot of Claude's videos, if you see on his page, and of course, what you guys learned through a three-way handshake, there's messages that have to be sent back and forth from a client and a server. Okay, and so what Wireshark dictates that has is a conversation, and it's not just with TCP, with UDP. There can be a conversation as well. It relies on from a source to a destination. Okay, so in Wireshark, there's ways to where we can follow that. Okay, and as far as it comes to troubleshooting, we can use that feature to see why something isn't working. Okay, maybe there's PCs within your organization that cannot get out of the network. They can't connect to websites. Maybe they can just ping to ping Google. Maybe they just can't reach Google. Maybe they can get to Twitter, but maybe they can't ping it. How do we find out if it's working or not, right? A couple of other tools we can use, but this time we're going to use Wireshark. So let me go ahead and break down what our topology is. Simple topology, right? Here's a PC representing roughly 100 or 200 PCs within the organization. I got one switch one. I'm going to go ahead and mute you. What's up? It looks like, okay. So yeah, the switch representing roughly, 100, 200 switches, right, in organizations. And of course, we have our exit point. We have a layer 3 device. We have a firewall, next generation firewall that's, of course, routing traffic, but also doing some IDS, IPS, looking at that traffic, filtering based on their ported, the port number, based on, layer 7 information, maybe some, other layers within the OSI model information. So that's the great thing about FortiGate. But, right, we have an issue, okay? I have my PC here. Let me go ahead and pull it up. And, I had a client, right? They're not able to, reach any websites or what have you, but they're able to ping any websites. It's very weird. I don't understand what's going on. So we're going to go ahead, right, and use everything that we've learned to this point, but adding another tool to our tool set and using the conversation feature to follow what's going on, right, and why packets aren't flowing out. So let's go ahead and log in. And before I get started, guys, any questions so far? Patrick, Wayne, Zamir, Max, Claude, Alex, feel free to stop me whenever you guys get stuck or what have you, or if I'm not making sense, I'll be more than happy to stop and, find an answer for you.
All right.
All right. So, like I said, right, the initial problem that was stated from the client, they can ping, external sites, but they cannot go ahead and reach out to different sites. They can't go ahead and use their fully qualified domain name to reach that site, right? Patrick, of course, you being an engineer, you're a network engineer, you're probably your first thing is gonna be, yo, it's probably DNS, hit up the Windows team. Am I right or am I wrong?
Yeah.
Right? But there's other things, right? Us being either network engineers or cybersecurity folks, there's things that we have to verify to make sure that everything is working, working as it's supposed to be before we disqualify or we push something to say, hey, it's this. We have to provide evidence because as engineers, we're scientists, okay? So we need to provide evidence. So first thing we're gonna do, okay? We're gonna try to recreate the customer's issue. We're gonna see if we can ping Google, and we're gonna see if we can get to Google from their PC, okay? So let's go ahead. I'm gonna go ahead and ping 8.8.8.8. That works fine. That's flowing fine. So we'll go ahead and let this keep pinging. Let's go ahead and open up a website, see if we can get to Google. it. See if we can get there. Okay. Let it load, let it load. While that's loading, you know, just for the sake of comparison, let's try another website while we're waiting. Okay, and let's go ahead and tie in the third one in there. Let's go ahead and fill up the, you know, the link and see what's going on. Okay. Okay. Nothing. Now, let's go ahead and test this. Let's see if I can ping it from its fully qualified domain name, okay? See if that'll work. Not looking like it. Not looking like it. And let's try YouTube as well. Let's try to ping YouTube directly. Nothing. Got nothing. Okay. Cool. And it tells us right there, temporary failure in name resolution. But Alex, does this tell you that it's solely DNS? So if I was a senior network engineer and you see this, does this solely tell you that we just need to look at DNS?
I wouldn't say. I would say no. It could be local DNS issue, or it could be workstation issues not pointing to, doesn't have the right DNS info.
Mm-hmm. Perfect. Perfect.
Gotcha.
No, excellent. Excellent. No, great job. So let's go ahead. The test. Let's still keep this rolling. What we're going to do, we're going to go ahead and start some captures. And I believe I already started it. Got captures rolling. Clear that out. Got captures rolling. See pings, they're going, right? Okay. So what I'm going to do is we're going to start, you know, use a feature I told you guys about. We're going to follow this conversation. We're going to follow the pings. So what we're going to do, click on a random ping. Yeah, I caught it. Oops. There we go. Okay. And here's what we're going to do. Okay. So we're going to see that conversation. Okay. We're going to see it between my host, right? That test PC we got is .26, and we're going to see it between Google. We see pings are able to happen. You know, they're able to reach it or what have you. Everything's working fine. Let's pull this up a little bit. Okay. So that's working there, right? But when we look at this, right? We look at, let's move over to this next packet. TCP, more than likely. What I'm looking for, where is the one I'm looking for? Should be here somewhere. Yep, absolutely. So guys, port 53, right? Can anybody tell me what that is?
DNS.
There we go. Who was that, Samir?
No, I had just came off mute. I was about to say it, but someone else said it.
Okay, no, it's all good. But guys, this is good, right? So we have, right? We're looking at this. We have TCP retransmissions for DNS, right? We have our evidence, right? SIMs are being sent, right? And if we look deeper, Wireshark is telling us, damn, we're seeing it, you know, it might just be a retransmission, bro. This is what we're seeing, right? And if you look at the whole conversation, right? And guys, if you see this, let me get my handy dandy note thingy and make this a little bit. Draw? Yeah, I can draw. Does it let me? Yeah, I think it'll let me. Okay. You guys see that right there?
Yeah.
What do you guys think that is?
Probably the group
What do you
of,
think that's showing?
it's just the group from the TCP, SYN all the way to the air retransmission.
Exactamundo. That's the conversation. Okay. Now we're gonna watch this in live action. I had to stop it, so it didn't let me do what I actually wanted it to do. So I'm gonna have to go ahead and process another capture.
Dave, can you rephrase that? What is that again? The group of what?
Those are the group of packets that are within a conversation.
Okay.
That makes sense?
Yes.
Okay. Okay. So this packet capture, just let you guys know, this is egress out the FortiGate towards my ISP. Okay. So now I'm going to capture ingress right to the FortiGate from my Eve local area network. Okay. And just as a refresher, anybody can tell me the difference between ingress and egress?
Ingress is coming in, packets coming in, and egress will be packets exiting the interface.
Depending on what?
The in respect to the actual device that you were like using. So it's relative to that particular device that you're looking at.
Excellent, excellent. So exactly what Patrick said, right? It's based on the direction of the traffic, right? Because my PC, right? If we're looking at, and this is just a refresher. So, and again, Alex said it before we started recording as far as knowing terms within the field, right? This can be my source and the net can be my destination. As far as it, if we're, determining ingress and egress on the FortiGate, ingress can be here, could be at port 2 if PC1 is my source, but ingress can also be at port 1 if the net is my source. Does that make sense?
Yeah.
Okay, perfect, perfect. Okay, so now we have our capture going on the ingress interface on the FortiGate. We have it rolling. So now we're gonna go ahead, pull that back up, see if we can populate some of that traffic. We're going to stop those pings. We know that works. Let's roll it. Nasty. Jesus. Nothing. Nothing, right? And so, and we're going to see, you guys are going to see the result of when it's in a working state looking at this screen. But right now it's going to be blank. The reason being because it doesn't have any packets that it captured that's actually in a working state. Okay, whenever it has retransmissions, it's not going to follow the stream because, again, let's talk about how TCP works. Three-way handshake, right? SYN, SYN-ACK, and then an ACK, correct? And of course, also with a FIN at the end. But that's typically how the conversation goes, correct? Somebody keep me honest here.
Yeah, Sinagana.
Perf. Excellent, excellent. So that's not happening, right? And so here's where ingress and egress is going to come in and how we're going to combine it with Wireshark and of course following a stream. Okay, so we're capturing packets on the ingress interface as it respects to PC1 being our source. Now let's go ahead and capture it on the FortiGate egress interface towards the net. Okay, so if we look here, we have that rolling, right? We have, our PC1 requesting, information about that website, okay?
Yeah.
And let's go down. And nothing. Nothing. Still have things rolling. Now, why do you guys think this is the case? And I'm going to capture a clean one just in case. But what do you think, and I guess the better question is, what do you think Wireshark can tell you about this traffic?
That interface on port 1 is not even it's not even getting the packet. It's not even passing it over to it, I'm assuming.
My man, exactamundo. Exactamundo. Excellent. Excellent. But Patrick, what would you need to determine that?
What would I need? I'll I would try to ping what that interface IP from, I guess, my packet 1. I mean my PC 1. Well, no, because it's a different network segment. So, that's a good question. How would I know? PC 1 or.
And again, conversation, right? That's the big key word. Conversation happens between two endpoints. So you got to have a source and a destination.
Right.
Packets have to leave someplace and they have to come back. So you have your source IP address and your destination IP address, correct?
Mm-hmm.
That makes sense, right?
Yeah. Yeah.
So you need those two things. Once you know that, because again, you guys see it, there's a lot of information that traverses a Wireshark capture. Now, again, this is in a virtual environment. This is just in a test environment. Imagine, right? Remember the scenario I set up. Imagine if it's one building, right? Let's say it's one building that Patrick, you and Alex are managing, right? You guys, each floor, you have 100 clients, 100 end users, endpoints on each floor. And you guys are troubleshooting at the data center on floor 1. And you have a Wireshark capture on, hold on. You have a Wireshark capture on that, mirroring from that Ingress interface from your aggregation layer switch to your data center core switch. That's a lot of traffic, isn't it?
A whole lot, yeah.
So here's the thing here's the point I'm trying to get to. As long as you know what you're looking for within Wireshark, you know the conversation, right, that you need to track, you will never have an issue of being overwhelmed with Wireshark. Because I don't know about you guys, but I was overwhelmed when I first started working with Wireshark. Okay, I'm not sure if anybody else can relate, but it's a lot of information traversing through Wireshark. Right now, guys, what I'm doing in my virtual environment, I'm restarting the FortiGate just because I may have some issues because I'm pulling too much, I'm doing too much packet captures. Of course, you guys will probably, have that issue in the field as well because and I think Paul can probably, talk about it as well. But right, if your PC, right, you have a lot of, packets coming, getting mirrored to your PC could lock up. You can't do a Wireshark capture for for a minute, 2 minutes. Again, let's check back at the scenario. Patrick and Alex are at the data center core, trying to mirror packets ingress from your local area network into that data center core switch. That's a lot of packets. Patrick's PC can shut down. So as long as you know what you're looking for. And guys, I'll put the link to Maxwell's video. Max posted a great video, okay? As long as you know what you're looking for, you will never have an issue with Wireshark and being able to decipher and analyze what you're trying to troubleshoot, okay?
Gotcha.
Let's see if everything is back up. And guys, let me bring the FortiGate GUI. I know you guys are studying for FortiGate, but I'm going to bring it over, show you guys what it looks like. Not sure if any of you guys played with FortiGates already. Real popular firewall that's getting a lot of recognition. A lot of people are implementing them in their environment just for its flexibility, what have you. Oh,
Yeah, I've seen it here and there. What I was liking was you can create policies.
Alex, expound more on that, man. What do you mean?
It's been a while. I was kind of messing with FortiGate just in my lab, and because I like to do reports. I like to mess around with that stuff. So I noticed you could do like policy based reports, and it just depends on what you're trying to capture on FortiGate. You know, if you're trying to capture specific packages, or I think, correct me if I'm wrong, but applying policies to interfaces.
Yep, absolutely.
I mean, it seems like they make it a lot easier, especially like related to Meraki. It's like a lot of GUI interfacing.
Yeah, and the funny thing, right? And I know, I think me and Claude was talking about it earlier. They tell you guys, oh man, stay in the CLI, and they tell all of us, stay in the CLI and stuff like that, so you can be sharp on your skills. But with FortiGate, there's, and there's a gentleman named FortiGuru. You can look it up on YouTube. He'll tell you there's certain things you can do in the CLI, and there's certain things you can do in the GUI. And this is just how FortiGate built their stuff, because they want it to just be plug and play. True plug and play. There's companies that say they're plug and play. Put me in front of a Cisco Firepower, probably going to be confused. Probably got to look at some documentation. So, that's how it is. So, we're capturing this. Let's go ahead and pull up our test PC. And Twan, thanks for joining. Just to bring you up to speed, what we're doing, right? We have an environment, right?
Right.
And I'm showing these gentlemen, showing everybody how to troubleshoot an issue using the conversation feature, how to track a conversation within Wireshark, see what's going on or what have you. Again, we went over Ingress and Egress. I believe it was Zamir, Maxwell, Patrick, and Alex that gave a refresher and definition on Ingress and Egress. And I believe the explanation was it depends on the flow of traffic. Who's your source and who's your destination. Okay.
Right.
All right. So this is our topology. We have our PC. This is representing 50 PCs on a floor. Okay. This switch is representing 50 switches. Okay. And it's all plugging into a core device, right? And for this, it's it's our layer 3. It's our FortiGate. It's doing some layer 3. It's doing some IDS, IPS. It's looking at all layers within the OSI model, which is why they call it the next generation firewall. It's looking at everything, within that packet, depending on what we have configured to see, hey, do we want to allow it or do we want to deny it? So different type of firewall. Won't get into that, but we're trying to check to see why our PC can ping Google, right? Because this is a complaint from the end user, but it can't reach Google based on its fully qualified domain name within an internet browser. Okay. Any questions?
No questions, but it could also be, and I didn't quite see all the capture for the DNS query, but it could also be the query could be going out to the internet, but it could be filtered coming back in.
Claude. Oh man. Claude, I think we got an engineer on our hands, man.
Yeah. You know what? It's actually your lab that you guys did for setting up DHCP. It was one of the earlier labs. I couldn't join that video, but I mocked it, and I was having issues with DHCP. And I found out, oh, I didn't have a route back to my PC. Huh. No wonder DHCP didn't respond.
All good. All good. All good. So guys, again, right? We're going to go ahead and follow this conversation, okay? What I did was I right-clicked the packet, right, that I wanted to follow. Of course, I filtered it down, again, using a protocol that I just want to follow, which is TCP, right? That needs to be used first before it establishes a connection between if I'm using HTTP and it's trying to communicate with a server, right, it does that three-way handshake. So I use TCP as my filter, right, in my bar, and I went ahead and right-click one of the packets, and I scrolled down to conversation filter, right, and I'm going to go ahead and go to Ethernet, okay? I'm going to go ahead and filter all the conversations, okay? All the conversations on that link. Somebody's coming in, okay, right? And it's going to show me everything that's traversing. I don't need all this. I really don't. I don't need all this. So let's drill it down. Like we did before. Okay. Of course, while it's not in a working state, I won't be able to follow the TCP string. Alex, just like I told you, there's another feature. Follow TCP string. This is another way to follow the conversation. If I click this, it's not tracking anything because nothing's working. Okay? Now, guys, just to fill you in, I know we're coming up on time. The reason why this is not working, I want you guys to remember your OSI model. You don't have to know about FortiGates to understand this.
Okay.
What layers? What do you think it is, Alex? What do you think?
I mean, it looks like you allow all ICMP only, but everything else is denied.
Excellent. Excellent. So me thinking as an engineer, I'm saying, okay, Ingress, right? Looking at my packets, right? Because let's go back. Go back and take a look at this.
That would explain why you can ping out, because it allows ping.
Right.
Mm-hmm.
Yeah. It's funny because usually pings will be blocked, you know, to avoid the excuse me, like DOS attacks.
Mm-hmm. Absolutely. So we see, right? We see there's DNS queries being shot out to my gateway. Gateway being my L3 boundary being the FortiGate, right? Port 2, right? It's being shot out. But using the Wireshark, right? Patrick and Alex troubleshooting this at their core, right? They're not seeing that packet come out. Egress, right? They're not seeing anything come from there to go to Google.
Yeah.
Seeing that there's no conversation. Not even getting out.
Yeah.
With that conversation feature, right? And again, guys, just to fill you in, all these are popping up because again, I had to create a connection to this so that I can go ahead and get into the GUI. So that's why we're seeing all these packets flow up. This is not from our test PC. This is from from my network. Yeah, this is from my home local network communicating with the virtual FortiGate. But we don't see anything, right? We don't see 10.10.10.26, right? And I don't have no NAT going on. So there's no NATing happening. So there's we don't see that populating. So something's weird, right? That's how we can follow that, right? And of course, being engineers, you're going to go ahead and check your firewall. You know, you check your switch, right? We already know at this point, if we're seeing the packets reach here, the conversation is already, you know, flowing through the switch. It's reaching the FortiGate. We already followed the conversation from 10.10.10.26. You know, we're getting retransmissions. We're following that conversation, right? But looking more deeply, we're seeing a lot of retransmissions. So that tells me that conversation that it wants to start with that server, it can't.
Yeah.
This is what the conversation is telling me. And even if I go out of here, right? capturing. I'm seeing here. I'm not seeing anything. If I even go,
Can I ask you a question? I know you said we can ask a question. I just want to make sure I don't get
absolutely.
lost. How are you able to see the ingress, egress? Like, where's that part showing up? I see all the protocols. I see the destination, the source. Where do you know that that one part, the ingress not coming in, like the information not coming in? How are you identifying that? Oh, through here.
Let me ask the question again. No, ask the question again.
So when you were saying that this is telling you the conversation that, maybe the packet wasn't coming through, which I'm assuming is ingress, how are you able to identify that from looking right here? I see like everything on here.
Perfect question. Perfect question. And,
Can I try to answer?
And this is what.
Can I, John?
Alex, go ahead. Yeah, Alex, go ahead. Yeah,
Well,
Alex Swan.
well.
Hey, guys, go ahead, please.
Wait, can't you determine the flow of the traffic based on the source and destination?
You can. You can.
Yeah, that's a good point too, because you could tell if you're getting a reply from outside outside the network. But also, if you go back to the capture, you can see the retransmission. And we go back to the OSI model. We talk about TCP/IP, and you look at the sequence number; it hasn't changed.
Mm.
Oh, okay.
Mm.
Okay. And there's one last thing, Zamir, right? Because I think this was your true question. The reason why we can tell this is because you have to understand the three-way handshake.
Oh yeah, we sent it over.
Right?
It's acknowledge, send back.
If my source sends a SYN, Juan, what am I supposed to get back from the server if I send a SYN?
Acknowledgement. Yeah.
A SYN ACK, right? And then
Alex.
And then Alex, right? I would go ahead and make sure, right? Me being the client, I would say, perfect. I received, right? I receive your SYN ACK. I'm acknowledging, right? I'm sending an ACK back to the server saying, hey, I acknowledged it. Let's go ahead and, start negotiating window size or what have you. And this is Claude's realm. So guys, please, this is where I get lost. But that's how it works. As long as you know your protocols, you know how they work, you know how traffic flows. That's a big part of looking into Wireshark. If you do not know the fundamentals in your CCNA and your network, your Net Plus or what have you, but you're working as an engineer or network technician and don't know how, traffic flows or what have you and how those protocols work, you're going to be a lost cause.
Mm-hmm.
It's super important to know the fundamentals and know how traffic flows. And guys, you can do this in your own lab. You don't have to have a big topology. I know on LinkedIn, they'll have 3,000 nodes. I mean, kudos to them. A lot of the, men and women that I see that do that still cause tax. So, again, use this lab, use your physical lab, that you have at home just to get the proof of concept. Once you guys understand just how it works, because I know you guys know how some protocols work, like Spanning Tree, Zamir, Patrick, like DHCP, Antoine, Alex, like OSPF, Claude, Claude turns into somebody else when you talk about layer 3. You say something wrong, he's getting on you, okay? But that's typically how it works, okay? So here's a review, guys. Again, you can use that, you can go ahead and use that conversation feature, use, looking up by that protocol within this search button to go ahead and see, hey, how's the conversation looking? And Alex said something perfect, guys. Look at that port number. Did it ever change? No. So that endpoint is still trying to send packets out using that same port number. Follow the conversation. Know the protocol. I guarantee you Wireshark will not be, it won't be overwhelming, okay? So let's go ahead and fix this, okay? Let's go ahead and make sure we can get traffic flowing.
Before you do that, Dave, I got a quick question. So if we didn't have the the actual rule in there to the implicit deny on a firewall, that ephemeral port number that they're having, like the 49,792, would that increase by 1 on the return? No, it can't be on the return because it'll be that 50 port 53. I'm just trying to think, like, what number would it will be expecting, or is that just saying that's the like the sequence number, or the session? I must say, I'm trying to.
No, that's a good question. No, that's a good question, Pat. No, good question.
Mm-hmm.
So let's talk about how Inferno, port numbers work. Right, they're randomly assigned.
Mm-hmm.
Okay, from that PC. Okay, so again, it's going to be randomized every time.
Okay.
It's going to search what's open, what's available, and it's going to assign that port number. But based on the protocol, right? Based on the protocol that it needs to communicate with, the destination is going to be different, right? And it's using again what's previously, what is right at layer 7 going on down, right? Because it has to encapsulate the request, right?
Yeah.
Oh, okay. They're at layer 7. It looks like they're trying to communicate with the DHCP server or DNS. So I know what protocol to use and what port to use has my destination port or what have you. Or if I'm a server, perfect. I know I need to use port 53 to go ahead and communicate.
Gotcha.
Right? To identify myself as a server, right? And so that's where, again, knowing the process, knowing how de-encapsulation works or what have you. Okay.
And it does it 3 times based on that, like that window, because I see like it does it 3 times. It looks like that. Well, I don't know if it's 3 times. No, never mind. You can scratch that. I'm just saying like the retransmission. So it tries it once, then it tries it again, and then it tries it. It looks like it tries it like 3 or 4 times, and then it changes the port number. Okay, cool. That's just good.
Yeah, and then the sequence number didn't change. So if we scroll a little bit to the right, you can see the sequence number is still 0. Correct me if I'm wrong. I think the sequence number should increment every time there's a handshake.
That's what I was trying to think as far as like, okay, what step is it on? There has to be some way to like, so that's what it is, a sequence number. Okay, cool.
Well, once Dave fixes it, then I think we should be able to
see
the sequence number.
Yeah, we can. That's good.
And then this reminds me, the retransmission, this reminds me learning about, what is it called? The random, when TCP, okay, so if there's like the transmission window, I guess there's too many transmissions, then TCP automatically like makes the window size smaller, and then they all at the same time make the window bigger. So it causes this sort of like wave of traffic. And so this kind of reminds me of that. This is just kind of a side talk about, I'm learning about QoS and stuff like that.
The window size?
Right. So like there's too many retransmissions. Let's say 50 clients are retransmitting, and then the switch sees that, right? Oh, there's way too many retransmissions. TCP automatically lowers the window size so that there's so they're not all like hogging the bandwidth. I totally probably chop that up, but this, just looking at this, so it kind of reminds me of that. Just another lesson I'm learning on another part of my CCNA here. But the window size isn't changing here. This just kind of jogged my memory about another info I'm reading about.
No, because the term window size just kind of like rang a bell in my head. Like, I know I heard the term before, dealing with TCP IP, and I just reminded me after this. I'm just gonna look it up just to like,
Yeah,
I know I'm gonna sleep on that.
I'll throw it on chat. See if I can find it.
Twan, you and I had a conversation about this on I think it was like right after I came in y'all Discord channel a while back, and I used the analogy of a telephone conversation.
Yes.
You remember?
Yes.
Okay, so I also told you, I said, once we get past the whole, you calling me and making sure it's me on the line, and I'm acknowledging you that, yeah, this is me, and you getting that confirmation. But remember, I told you, I said, if I'm doing something at that moment, I'm going to tell you to stop talking or either slow down your talking.
Yes. I remember. Yeah.
Okay. So that's window sizing. you got a message to tell me, because that's the reason why you called me, and you eager to tell me, but I'm doing something at that moment. I'm answering the door. I got some bacon cooking on the stove. I got to tend to real quick. So before you start rattling off what you got to say, I'm telling you to slow down, because I don't want to miss nothing.
Mm-hmm. And then I think it also says, okay, I received those 4. I'm ready for 4 more.
Some more.
Or something like that. Yeah.
And then once I answer my door, find out it's the mailman, or once I turn my stove off, then I'm able to accept more of the conversation that Twan's sending. And then we agree on, a certain size of conversation that we can both agree on to send back and forth. Remember that conversation? You remember that conversation, don't you?
Yes, I do.
There it is.
I do now. I do now.
now.
Now everything started. Yeah, now it makes sense. Well, more sense, I should say. Them jams, man, boy, they know how to. It all come together when you need it.
All right, cool. Everything's coming back up. And
Man, Claude's like a cobra. He's just waiting. He's just waiting. Bam, he
fly on
strikes.
the wall. Hey, man, listen. He's Mace Windu, man. He's Mace Windu.
He's like that old janitor at your high school. He'll drop some knowledge on you. You're not gonna use it right then. You're not gonna appreciate it right then. But sometime in your life, you're gonna look back and say, man.
Hey, Claude know a lot of stuff. Claude's daughter gonna be running laps around us in about 5 years.
What?
Mhm.
2
Listen,
years.
listen. If she ain't helping me troubleshoot a BGP issue, we gonna have some problems.
Well, right now we just gotta get chess under our belts first. We gotta get the game of chess under the belts. She ain't she see me back here playing with these boxes, but it don't got her attention right now.
Yes. One day I got my oldest nephew 18, but I got 3 the second round. They all 3 twins, and my niece Legacy. There's 2 boys and a girl, and I'll be like, by the time they 9 or 10, they gonna be like the other ones when I was young. They're gonna be on networking, all this every time they come over, so we do anything.
Now I'll tell you one thing. She can navigate a tablet or a smartphone better than I can. And
get the chest app.
Yeah, I tell you what, I know we all joke about me coming off the BlackBerry and all that good stuff, but she this little kindergartner right here, she navigate that smartphone, that iOS.
Look, she offers something to you. Look, all this technology that she like, I got you. I can show you how to get there.
Yeah. It's right here. It's right here, Daddy. Don't you see it?
Like, right. She's like, what's wrong with him? I don't even know how much you really know. She's like, you can't do this. It's right here.
I miss my BlackBerry. I'm not gonna lie to you.
Don't get it.
Don't get them started. Don't get them started. Don't get these guys started. I'm glad Brian ain't.
What is it? 2022.
I'm glad Brian ain't in here.
2022. I just recently gave. What is it? Like it was 2017. I gave it up for an Android.
He's really thinking about it.
I did.
That's killing me right now.
Had my Z10. It was a Z something.
Yeah, that was the latest one. Yeah, that was them trying to come back. Yep.
And hey, Claude, listen, I listen. No matter what they try to tell me, try to give them my black. Listen, I had IG with the there was a BlackBerry had a great way of whoever the developers were, they had a great way of simulating or copying the actual application. So we had our own version of IG and Uber. Boy, you couldn't tell. I was catching my Uber coming from work in the city,
Yeah.
And it wasn't really an Uber app. I was like, man, well, I need an Android or iPhone for.
IP. All right, now let's go ahead. In my gateway. First. Okay. And the outside. First. Okay. Let's see. This will work now. Oh, got the Google.
Looks like it's working.
Let's see if I can get to Twitter. Oh man. So now let's do some captures. Okay, let's see the difference. And again, it's me, Alex, and Patrick trying to troubleshoot this in the data center. Okay, so we're gonna see the difference after the security guy, Zamir, changed his firewall rules. So we always gotta blame it on
He must have
security.
just started like, hey, we gotta secure this network. Let me make this change real quick.
It's always a network engineering team that just throw shots at security. Jeez. Y'all are petty. All right, cool. Okay, so over. So that packet's flowing, right? We got our packet captures going. Okay, this is outside, of course, because of course it's showing us the IP subnet of my local area network, which is 192.168.1.0, showing all IP addresses there. This is inside. Okay, so let's go ahead. Let's pop open a web browser again. Let's see if we can go to Google. Oh, look at that. Flowing. Okay, now let's open up Google. Okay. Let's look up, I don't know.
I was gonna say it's gonna be actual berries.
Damn, Claude. Damn, they don't even got the phone on there no more. They got fruit. Damn,
You
they
know
just
what?
took you off Google.
I ain't even messing with y'all.
All right,
I ain't even messing with y'all.
All right. Cool. So we have, we also have pings flowing as well using the address. It's going. So now we got that going. Let's go ahead and shut everything off. All right. Again, we're gonna mimic this as the environment. Okay. So inside, right? TCP.
And
We're going to be
IP adder.
No. We're going to do 10.10. Oops. 10.10.10. Okay. Okay, so we have the stream telling us it's flowing, right? We're able to follow the stream now, but also, where are we? Okay, now we can look strictly at the conversation. Okay, so we have our SYN, we have our SYN act, we have our act. Tell us it's a success. It's rolling, right? And this is the entire conversation, right? And Patrick, remember what we just talked about. We have our source, 10.10.10.26. We have our destination, 34.107.221.82. As long as we know those two things, and we know what protocol that's trying to traverse through our source and our destination, here's how we can use Wireshark to combine all those together and to follow a conversation and see, hey, cool, here's why endpoints aren't able to flow, throughout our network. Okay?
Yeah.
Make sense, guys?
Yes, sir. It's perfect.
Plenty of tools within Wireshark. Wireshark, again, is just another tool for your tool belt as an engineer. Don't just rely on that. There's plenty of other tools, switches nowadays, of course, Cisco 9000, 9000 series or what have you, they actually have something called embedded packet captures where you can do a packet capture on the actual device. I am working on, bringing in a Cisco 9K device in so we can go ahead and see how that works, and how you can apply what you learned about Wireshark in your practical analysis book or what have you that was provided to you, or anything you know about Wireshark, you can apply that to everywhere, because again, all these, right, the and or what have you, the comparison operators or what have you, all this comes from Linux. Wireshark was based on Linux, okay? So, knowing the basics, knowing the fundamentals, guys, it all comes together. With that being said, our meeting is done. So that was part 3. Any questions, guys, before we hop off?
That was great.
Yeah, thank you.
That was dope. That was dope.
Yeah, most def. Most def. All right, fellas. Well, I'll go ahead and end it here. Again, the recording will be put up shortly. And again, feel free to reach out, guys, if something didn't make sense, if you just need some clarity. Anybody in the group, and I believe, there's a whole bunch of folks that touch Wireshark, like Alex, like Patrick, like myself, Claude, Max has a video on it as well. Feel free to reach out to these guys and start playing with it, okay?
Yeah, that video,
All right, folks.
Good job, guys. Good job.
Thanks, everyone.
Yeah, that was a great video. That was
Yeah.
a great video by Max. Again, I'll
Yes,
post
it
it as well.
was. Yes, it
I'll
was.
check that out.
Yeah, I'll check it out too. Awesome,
too.
awesome. Thanks, guys.
Y'all have a nice
All right.
All right, folks.
All right now.
Good night.
You guys
Thank
have a
you.
good one.
Good night.
Good night, team.